So today we're going to be looking at finding your X and Y intercepts of graphs, and this is an important tool because you're going to be able to you need to be able to use this right the way until you get your cubic graphs and matrix. So although our focus this year is the straight line graph, we need to look at generally finding X and Y intercepts. So two important points. Your y-intercept is a point on the y-axis, and remember all points on the y-axis have the x-coordinate 0. So if you're trying to find your y-intercept, it's always going to be the point 0 something. And to find that something, you're going to substitute x equals 0 into your equation and solve for y. Similarly, if you're looking for the x-intercept, it is where your graph cuts the x-axis. So it's a point on the x-axis, and every point on the x-axis has the y-coordinate of 0. So those points will always be something 0. So to find them, we're going to substitute y equals 0 into my equation and solve. So we need to just refresh our memories. This is your x and y axis. So remember, when you're looking for your x and your y axis, you need to remember that your horizontal axis is your x axis, your vertical axis is your y axis. That's why anywhere on the x axis, which coordinate is 0? The y coordinate is 0. But when you're on the y axis, which coordinate is 0? It's always the x coordinate that's equal to 0, because it's in line with 0 on the x axis. So that you just need to keep in mind. That's why when you're looking for the y-intercept, you make x equals to 0, and when you're looking for the x-intercept, you make y equal to 0. So we're going to look at a couple of examples. So we're going to start with the equation x plus y equals 4 while we're talking about equations. Notice it's the equation of a straight line. You've got an x value, a y value, and a constant. So in this case, we're going to have a distinct x and y intercept. So remember, how do we find the y-intercept? Well, to find the y-intercept, you're going to make x naught. So if x is naught, we've got naught plus y equals 4. Which means y is 4. So when x is naught, y is 4. And that's going to give me my y-intercept. To find my x-intercept, we're going to make y equals 0. And if y equals 0, you're going x plus 0 equals 4. So x is 4. So what did we say? X is 4 when y is 0. In terms of sketching, we'll worry about that just now. We're just worrying about finding x and y intercepts this time round. Okay, so again we have a straight line graph, which we can identify by the fact that you have an x term, a y term, and a constant. So the fact that we got all three of those terms tells me that I'm going to have a different x and y intercept. In other words, it doesn't go through the origin. All right, so again we're going to find my y-intercept. How do I find my y-intercept? I make x 0. So we've got 2 times 0 plus 6y equals negative 12. Now obviously 2 times 0 is 0, so we can basically ignore that. 6y equals negative 12, so y is negative 2. So in terms of points, what did we discover? That when x is 0, y is negative 2. That's a point on your y-axis. To find my x-intercept, again, same old story, you're going to make the y value 0, because anywhere on the y-axis, y is 0. And obviously 6 times 0 is 0, so that term's gone. If you're doing this in your book, you might sometimes just find it easier to just put your finger over the term that disappears. So 2x equals negative 12, so x is negative 6. In terms of the coordinate points, what did we say? When y was 0, x was negative 6. So 0, 2 is your point on the y-axis, and negative 6, 0 is your point on the x-axis. 2y equals x plus 5. Again, you've got a y term, an x term, and a constant, so it is a straight line that cuts the x and the y-axis at different points not going through the origin. So again, find your y-intercept. You're going to make x naught. So we've got 2y equals 0 plus 5. Obviously, you can ignore the 0. 0 plus 5 is 5. Divide by 2, so y is 5 over 2. Now, because we're drawing graphs, it's much easier to write that as 2.5. Normally, we don't bother to change fractions to mixed fractions. We say that it's just as simple to keep it as 5 over 2. But if you're trying to draw your graph, it does make sense. Okay, so if x is 0, y is 2.5. Makes sense because it's easier to find 2.5 than it is to find 5 over 2 on your axes. And my x-intercept, we're going to make y equal to 0. So 2 times 0 equals x plus 5. Now, obviously, 2 times 0 is 0. And you might find it easier to bring the 5 across and say, so negative 5 equals x. Which means that x is negative 5 when y is 0. So notice again, it's a distinct y-intercept, distinct x-intercept. You would plot them and draw your line through them. Oh, now this one looks different because here we've got x squared minus x. And now I've made a mistake because I really shouldn't have put that equal to 0 at this point. That should be saying y equals x squared minus x. I've jumped ahead of myself. Obviously, if I want to find the y-intercept, I'm going to make x equals to 0. So I'm going to have y equals 0 squared minus 0, which I don't know about you, but that's very obviously 0. So in other words, when x is 0, y is 0, and that's my y-intercept. To find my x-intercept, same old story, x squared minus x equals 0. But here, you don't just have a linear equation. We should be able to realize that we've got a small little problem because I've got this 2 up there. Okay, that highlighter maybe wasn't the best idea. Okay, but we've got a 2 up there, which implies that I have a quadratic equation. And remember, when we solve quadratics, we take everything to the left, 0 on the right, and factorize. Okay, so in this case, I've already got everything on the left and 0 on the right, so we're ready to factorize. And there is a common factor of x, and we're left with x minus 1. So remember, if you have something times something equals 0, then one of those factors, x or x minus 1, must be 0. So either x equals 0 or x minus 1 equals 0. Now, if x minus 1 is 0, then x is 1. So what happens here is we got two x values, x equals 0 and x equals 1, for when y is 0. That gives me two x-intercepts. So one is 0, 0, and the other one is 1, 0. We're not really going to be focused on drawing these types of graphs, but just for interest's sake, what that means is my graph goes through 0, 0 and through 1, 0, and in fact, it looks like that. You may remember from your lessons in class that that's called a parabola. Okay, the next type of graph we'll also realize is not a straight line graph, because a straight line graph does not have variable denominators in fractions. So let's have a look at this one and just see what's happening. If I want to find my y-intercept, I have to make x naught. So that's going to give me x equals negative 3 over 0. But whoops, that's a problem. Why is that a problem? Well, it's a problem because we cannot have a 0 denominator. So in other words, there is no y-intercept. So my graph does not cut the y-axis. Now, in a similar way, we need to find the x-intercept. So we're going to make y naught. So we're going 0 equals minus 3 over x. Now, what we normally do here, well, to get rid of the divide by x, you times the other side by x. So we're going to get 0 x equals minus 3. So 0 equals minus 3. Now, I don't know about you, but that clearly is yet another problem, because that's not possible. So, you're absolutely right. There is also no x-intercept. You may remember from class when you drew this that if you had to just find a whole lot of points and draw it, your graph would look like that. And remember, its name is a hyperbola, and you'll be studying those in grade 10. not so much grade 9. All right, my last graph, and again I was ahead of myself and made it 2 to the naught instead of 2 to the x. So we're going to be looking at the graph y equals 2 to the x, and again finding my y-intercept and my x-intercept. So remember, my y-intercept, we're going to make x 0. So y equals 2 to the 0, and let's see what you remember. Well, from exponents, 2 to the 0 is 1. So when x is 0, y is 1. And again, to find my x-intercepts, we're going to make y 0. So 2 to the x equals 0. Now, you might remember from exponential equations that what you're supposed to do here is try and get the same base on both sides. But 0 cannot be written as 2 to the anything. So clearly, yet again, we've got a little bit of a problem on our hands. Or is it really? Well, no. We just need to understand that there is no x-intercept. This is also a graph you'll be looking at more in grade 10. It's an exponential graph. If you want to understand what it looks like at this point, it's going to start down here. It's going to get, strangely enough, exponentially bigger, and it's going to pass you 1 on the y-axis. Okay, so the last few cases where the odd ones out, for you, it's really the most important that you can get the x and y intercepts of straight lines. So bye for now.